Good morning. I am Sandeep Nandi from Kalyani Government Engineering College. This is an introductory class for your digital communication system course. So these are the learning objectives. You will have the basic idea of the digital communication and some signal classifications, and you can find the signal energy and power at the end of the class, and you can solve the related problems at the end of this class. So first I will recall that what is a communication system. Communication system is to transfer an information from one point to another point through a medium. So you will see this is a basic general schematic of any type of communication system. You will find there is a source. This is the point from where we want to send the message, and this is the recipient where we want to send the message, and the recipient will receive that message. So what we will need first, the message from the source will be processed through a block that is called transmitter, and that signal, process signal, will be transmitted to the channel that is a medium, particular medium, and the processed signal will be received by a receiver at the recipient end, and that receiver signal will again reprocess the signal to send the original message to the recipient end actually. So this is the basic block diagram. Now before going to the digital communication system class, first we will study why we'll go for this digital system. Actually digital technique allow easier regeneration of the corrupted signal. Actually digital signal is a multi-level signaling, and it has discrete levels, and it is not actually called continuous, but it is a discrete. It contains discrete levels, so we can use threshold for the detection of the each levels, so it can easily be regenerated. There are some good processing techniques are available for digital communication, that is analog to digital converter and vice versa, data compression or source coding we call, and error correction or channel coding that will can implement with this digital signal. And there is an equalization, very important process that we can adopt for this digital signal case, because this is the important thing for the removal of the ISI. Also encryption and privacy is a very important phenomena for the digital signal. We can easily implement this encryption and privacy using this digital signal. Time division multiplexing is a very important case for this digital signal, and we can easily implement this multiplexing for the signals. So we can send different channels at a time through the same channel. Also digital signals are very immune to distortion and interference. So now we will discuss what is the task of the transmitter actually for digital communication system. The transmitter first task is to convert the analog signal to a digital signal using the process analog to digital conversion. Then it converts the digital bit sequence into an waveform ST, that is called the process modulation, and this bit sequence is can be sent bit by bit, or it can be sent by a symbol. Symbol is actually a collection of n number of bits, some number of bits actually. If we collect n number of bits to produce a symbol, then we can have m is equal to 2 to the power n number of different symbols. Suppose we collect 3 bits to produce a symbol, so we can have m is equal to 2 to the power 3 is equal to 8 different symbols. Symbol rate is defined as number of transmitted symbols per second. It is defined as RS, and it is also called baud rate from the telegraphic notation. So what is channel? Channel is a very physical medium. It can be a twisted pair, it can be a coaxial cable, it can be an optical fiber, or it is a wireless medium like atmosphere. So channel is actually a medium which carry the transmitted signal towards the receiver end. There are some impairments in the channel, that noise will affect the signal, noise will degrade the signal strength. Attenuation and distortion is also there to disrupt the signal. Crosstalk and interference is very important phenomena that will very often happen in the digital signal processing case. So at the end we can say that the received signal at the receiver end is not equal to the transmitted signal ST. It is likely some difference. So what is the task for the receiver? Receiver task is to receive the signal RT, and it convert the signal to analog signal using a digital to analog conversion. Receiver performance can be analyzed by some metric. The important metric is bit error probability or bit error rate. Bit error rate, BER, is defined as the ratio of number of bits in errors and number of transmitted bits. For example, voice signals when transmitted digitally has a bit error rate of 10 to the power minus 3, and the data directly transmitted is a bit error rate of 10 to the power minus 10. So how we can send the information? Actually, information will be converted to an electrical or electromagnetic or optical signals. So actually, for the communication purpose, signal plays a very important role. So digital system converts the bits, that is the digital bits, into digital signals actually. So we require to study something about the signals. First, there are some classification of signals. Different type of signals are available in the world. So first classification is deterministic and random signal. A deterministic signal has no uncertainty with respect to its value at any time. That for example, xt is equal to 5 cos 10t, it will you will find at any time a value for this signal xt. A random signal has some degree of uncertainty before the signal actually occurs. There is another classification, periodic and non-periodic signal. Periodic signal repeats itself after a certain period, but non-periodic signal do not repeat itself. Analog and discrete signal is another classification. Analog signal is a continuous function of time, and discrete signal is one that exists only at discrete times. It is characterized by a sequence of numbers. There is another important classification, that is energy and power signal. Energy signal xt is a signal if and only if it has a non-zero but finite energy for all the time. Energy signals can be both deterministic and non-periodic. A signal is defined as a power signal if and only if it has finite but non-zero power for all time. Periodic signals and random signals are often classified as the power signals. There are two very important terms that we can identify for the signals to study the signal, that is energy spectral density and power spectral density. You can see that energy spectral density, the signal energy per unit bandwidth, is called the energy spectral density and can be represented as by this formula, psi xf is equal to xf mod square. The energy spectral density may be symmetric in frequency. In general, it is symmetric in frequency, but may not be also in some special cases. But Ex, the energy, can be calculated directly from this ESD using this formula. Ex is equal to 2 integration 0 to infinity psi xf df, considering that the spectral density is symmetrical in frequency. But if it is not symmetrical, then this 2 will be omitted and the integration limit will be minus infinity to infinity. This is the formula to find out the power spectral density, PSD, GXF, and the average normalized power can be calculated directly from this PSD as Px is equal to minus infinity to infinity GXF df. So you can calculate PSD and ESD directly from the signal. Here is an example. Consider a signal xt is equal to the power minus 80 ut. Its energy Eg will be calculated as x square t dt and it will be equal to 1 by 2a. The spectrum xf can be found directly from the Fourier transform of xt, that will be equal to 1 by j 2 pi f plus a. And thus the ESD of the signal is calculated from this formula, psi xf is equal to xf mod square is equal to 1 by 4 pi square f square plus a square. So it's a very simple example how we can calculate the signal energy and the energy spectral density for any signal xt. So this is the end of the class. Thank you.